I'm Tunnicliffe. I'll be talking today a bit about the Edge Technologies program, what we've been looking at. I started in July as program lead, so I'll talk a little bit about myself for anyone that doesn't know me. A bit about drones and ROVs, particularly around condition monitoring, balance tank cleaning. I'll talk about VR induction training. We had a little stand at OzWater where we presented on training and inductions in VR. Talk about a virtual reality training platform, which is kind of the evolution of that, and augmented reality remote assistance capabilities, and a bit of a proof of concept around a worker of the future. So I started in July 2019 as the program lead. I've got nearly 10 years experience in the water industry. I've been at City West Water in a number of different roles over the last 10 years, predominantly through engineering, from drafting in standards and design to operating a treatment plant. These days I work in strategic projects and my role is to look at new and emerging technologies and identify how they can be applied to solve business problems. So it's like a lot of fun. Very good synchronicity with the Edge Technologies program. My interests are VR, AR, virtual reality and augmented reality, 3D printing, machine learning and robotics, drones, ROVs, anything that's a fun gadget I'm into. So drones and ROVs. I met with PricewaterhouseCoopers a month ago to talk about the applications of drone technology in the water industry. City West Water, we're probably very much in our infancy in that space, but I've been speaking with SG Water and Southern Rural Water about some of the different applications for drones. We've been looking at it from an asset verification point of view, but there's drones out there capable of doing thermal imaging. Up the top, this picture here is a sewer spill using a DJI Mavic 2 Enterprise Edition with the FLIR camera, but you'll also see people with the big Matrice octocopters that you can mount a payload on there. So you'll be there are utilities using thermal attachments on those drones. So yeah, terrain modelling is another big one. Southern Rural Water have been mapping out with a drone some of their sites in 3D. So these are photogrammetry models of a weir and a trunk sewer or something. And they're starting to sort of play in that digital twinning BIM space with that. We've used drones a little bit for condition monitoring, like inspecting tanks and hard to reach places, but I'll get on to ROVs, which is the next slide. So ROVs, remotely operated vehicles, there's a number of different solutions out there ranging anywhere from $1,500 to 20, 30 grand. This yellow one is called the Gladius Mini. It's being used currently at Melbourne Water to do tank inspections. It's less than $2,000, this device, and it's got a controller. It's like operating a game console, really. So very easy to use. It's got a 4K resolution camera on there, and for most tank sites, if you've got a long enough tether, it should be very much suitable. But we've also looked at some of the higher end solutions where you start to reach closer to that 30K mark, where you've got ROVs where you can put in a grabber arm or sky's the limit, any sort of sensors or anything on there. The market at the moment for ROVs in general, it's pretty competitive. So the prices over the last year or so have been just going down very rapidly. We've nominated the Gladius Mini as sort of a device of choice at the moment, and we're looking at in the next 6 to 12 months trialling that on a number of different tank sites, recycled water and potable water. Very interested to see how turbidity affects your vision in there. The next bit here. So going on from like condition monitoring, this is our Altona treatment plant. We have Previously had manned entry to clean the sludge at the bottom of the balance tank there. You had to drain the whole tank, get a crane in, put someone on a forklift, and then they pretty much just wipe the bottom clean. Obviously there's issues of putting a person in a balance tank. We actually did have an issue a few years ago where someone was in the tank and they started to release sewage back into the tank. So it got stopped straight away, and there was no there were no injuries or anything, but it was a pretty significant incident. And obviously important to explore other ways of doing it. I've been speaking with Watertight Robotics, who are at OzWater earlier in the year, and they have a device that is capable of doing that. The price of it is fairly high, especially considering transport costs. These companies in Perth, but we have some quotes that have just come back, and it's more expensive than the manned entry, but it's not ridiculously more expensive. So I think with the safety benefits of that, the business case will stack up. So once we do that, we've got to determine the viability of robotic balance tank cleaning and then share that in with the IWN. I have SEEK costings, but I've got the costings since then, which was around $47,000 to do the work to clean the tanks there. So it's actually a pretty basic job for them with this one, because it's a fairly small treatment plant. OzWater earlier in the year presented on virtual reality training. Some images here. This is the stand. These images are from the City West Water's first virtual asset tour, which was a virtual reality induction program that allowed new starters to go and get an appreciation of different asset sites while learning a little bit about them as well. So we've got the alternate treatment plant here. There's an inspection of a meter assembly with one of our compliance officers, and not knowing anything, you can put a headset on, you can scan a QR code, look at it on your phone, or you can just go on your computer and view these tours, and now you're able to go to a site without actually going there, which is pretty cool. So there's obviously time commitments that are reduced. There's less expenditure on PPE potentially, and what we found is when we used it with induction training, staff were engaged. They had a higher level of information retention. We did some tests afterwards, and it was the highlight of their induction. It can be pretty boring as the new starter getting some pretty heavy water industry training. So this kind of broke up their induction, and what we actually found that they were using it after the induction had finished in their day-to-day jobs. So when they wanted to know about a meter assembly, or about a treatment plant, or what a valve looks like, they were able to go back and look at that any time. So ongoing benefits from that. This training cost $0 to make. I used a free platform called VR. They're kind of like YouTube for virtual tours, and using drone footage, 360 panoramic views, a 360 camera, and then just grabbing graphics and voiceovers, which I recorded all myself, was able to build a tour, and it didn't cost anything. But the issue with a free platform is you don't have any analytics on the back of it, and it's not very scalable in a sort of enterprise environment. So I started to look at how do we scale this up, how do we have a formal process around virtual reality training, which led me to this platform called Warp VR. They have an enterprise level training platform for VR content that, again, you can use in a multi-platform sense. So you don't have to have the headset on. You can do it on a computer, on your phone. These have the potential to license out training modules. So what I'm hoping is that we can develop generic water industry training modules and then share them with the wider water industry, rather than just doing it in-house and keeping everything to ourselves. So the analytics side of that as well, you can report on the competency, so you can get some gradings at the end of a training package. You can see where they're paying attention. So if they're looking at the bird over here instead of the meter assembly with the information, they're probably a bit distracted and they may not have learned anything in that trial, but you're able to see that afterwards. We're currently looking at 2 proof of concept projects around a chemical delivery procedure at our alternative treatment plant and an induction package for our maintenance contractors at one of their sites. Yeah, it's still developing the business case for that. So yeah, watch this space. Also been looking at AR, which is, everyone thinks it's going to replace VR, but it has its own sort of niche. We're looking at some easy wins in the AR space because it's pretty confusing and muddled out there. So an easy application for this is remote assistance for, say, a subject matter expert or an engineer in the office. They're able to, with a device like this, connect with an electrician or an operator out in the field and see in real time what they can see, guide them, annotate their vision, as like this picture sort of shows, and they're able to, they're able to be there with the person standing over their shoulder, pretty much. There's a few different devices. I was looking at the HoloLens 2, which isn't out yet. It's the, if anyone knows about the HoloLens 1, it is a wearable device that has, it projects holographic images over your real world vision. And the limiting factor of that was the field of view. If you're looking at a digital person, you might see their head to the lower torso there. So it was a little bit limiting. It's very sort of in your face. It covers your whole vision, which not everyone wants to do, especially some operators and electricians out there. So we've looked at this RealWear HMT1. I met with the company just recently who have a device similar to the Google Glass. It's pretty much wearing a 7-inch floating tablet display in your vision, and you use voice commands to talk to it. It's rugged, it's ready, and it's available now. The price is $2,500 US. I think I scoped out 2 devices for a proof of concept at our treatment plants again, and it was about $7,000 or $7,500 to get 2 of those headsets. And straight away, you'll be able to see the benefits by providing operators at those treatment plants the ability to get support like they haven't had before. So it's hands-free. There's efficiency improvements through this sort of stuff, but it sort of leads into the next thing, which is the worker of the future piece that I'm working on. So that will involve a head-mounted display, such as the RealWear HMT1, a smartwatch with fall detection, heart rate monitoring, and GPS tracking, so potentially like a lone worker device. Looking at any device at the moment or app that will enable that sort of feature. Haven't settled on that yet, but then also having a tablet or a smartphone to integrate with those devices to sort of give you a bit of to sort of fill the gaps. So we're, again, 2 trial locations at ATP and our West Werribee salt reduction plant. It'll enable the remote support and monitoring, but the cool part of this is being able to, say, have a QR code on a pump or a piece of equipment and having guided workflows up on that device. So it might say step 1, isolate the power, and you're okay, continue. You can make notes, take a photo of what you've done, and it'll guide you through step by step. So potentially you can have a lower skill level for field workers, but they still have that those expert of the procedures at their in their vision. So the workflows pretty easy to do, but obviously they require a bit of development. So they're kind of going to be one of the results of that proof of concept. And yeah, there's this sort of project. I want to eventually create kind of like a best practice for your field workers. So fitting them with all the kit they need to do their job in this future world that we're living in today. Obviously the capabilities of all of this will increase over time as we expand into digital twinning and Industry 4.0 and all the fun stuff that's coming. But we've seen today there's a lot of work that needs to happen to get us ready for that space. But if we can start adopting some of the technology and getting those easy wins first, we're going to be better prepared for when that time comes.